Engine, the heart of a plane, works so majestically day in and day out, lifting pounds of weight in the air, working thousands of hours in its life cycle. But what if, after the relentless work, the heart fails, or safe to say, explodes?
Yes, sir, we're single engine descending, have a fire number 1.
Today we'll look into the story of Southwest Flight 1380, where the crew are left to deal with dual emergency at once, where training, thinking is put to a test, and time is of critical essence.
Mayday, mayday, mayday.
Wind shear.
Terrain ahead. Pull up.
Engine, according to me, is one of the greatest inventions done by any human. Cars, motorcycles, bus, truck, ships, train, and aeroplanes all require an engine to make it feel alive. Jet engine of modern aviation, also known as turbofan engines, are very efficient, less noisy, and very reliable when compared to its predecessors. A jet engine works on a very simple principle. It sucks the air through the engine inlet, compresses it inside the engine, ignites it with fuel, and then it is exhausted from the back of the engine. For today's story, we don't need to understand all the components, but just a few relevant to the story. Engine inlet is this part. Fan blade are that you see in the front of the engine. Fan case is protecting the inside of the engine, and engine cowl covers the engine from the side. Strong high-tech components inside the engine make sure that the engine stays reliable and efficient. But what if one of those components becomes the culprit for Southwest Flight 1380? On April 17, 2018, two pilots reported for duty at Nashville International Airport at 6 in the morning. They then operated a 2-hour flight to LaGuardia International Airport. The aircraft involved was Boeing 737-700, registered November 772 Sierra Whiskey. The aircraft was delivered to Southwest roughly 18 years ago, in July 2000. There were no technical defects on this airplane on this day. The aircraft accumulated a total of 63,521 hours with 37,021 flight cycles. One complete cycle of takeoff, pressurization of the aircraft, landing, depressurization is known as one flight cycle. The engine was a CFM56-7B manufactured in late 1997 and installed on this aircraft on November 29, 2012. The engine accumulated a total of 67,000 hours and 40,569 flight cycles. Engine hours means the total time the engine is running. Flight cycles, airframe, engine hours are measured to keep a track of component wear and tear, and for those which are caused by a repetition of stress. To this date, engines were mostly checked on the basis or number of hours of operation, not the flight cycles, but soon this will change. The accident flight was scheduled from LaGuardia Airport in Queens, New York, to Dallas Love Field Airport in Dallas, Texas. Both the crew were on the second day of a 4-day pairing. The captain of the flight was a very senior, 56 years old, who worked for the US Navy before joining Southwest 24 years ago. She flew LTU A-7 Corsair F-18 Hornet, completed her Boeing 737 type rating in 1993. She then upgraded to captain on 737 in the year 2000. She had a total of 11,1715 hours, out of which over 10,000 hours were on Boeing 737 and over 7,000 hours as a captain. She was a very experienced veteran pilot. The first officer, aged 44, was also with the US Air Force, flying Cessna T-37, Raytheon T-1 Jayhawk, Boeing E-3 Sentry aircraft. He joined Southwest 10 years ago, did his type rating on Boeing 737 in 2007. He had a total of 9,508 hours, with close to 7,000 hours on 737. Both the pilots were very experienced, with a good background of flying with the US Navy and US Air Force. In the cabin, there were 144 passengers, and looking out for their safety were 3 cabin crews. This made a total of 149 souls on board. They pushed back from the gate at 10:27 in the morning. After 16 minutes of taxi, they took off at 10:43 for a 3-hour flight towards Dallas. It was a beautiful sunny day to fly, with the first officer being the pilot flying and the captain being the pilot monitoring. Duties are often divided between both the pilots. The pilot who handles the takeoff and landing, conducts the departure arrival briefing, is known as pilot flying. The pilot who talks to the ATC, handles routine paperwork, is known as pilot monitoring or pilot not flying. But both the pilots should always, and they always do, monitor the aircraft performance and the system performance. In the cabin, the passengers were in a relaxed mood with the cabin crew preparing for service. At 10:57, they contacted New York Center, which instructed them to climb to flight level 380 or 38,000 feet above mean sea level. The pilots were doing routine monitoring of the aircraft systems performance like any other day at flying. Little did they know that soon this will change into the most challenging flight of their lives. 30 minutes into the flight, in the engine, things were getting to go out of control now. There was a low cycle fatigue crack developing from a long time in one of the fan blade dovetail of the left engine. Dovetail is the bottom flat part of the engine fan blade that goes into the disc that seals the fan blade into its position. A low cycle fatigue crack, as the name suggests, happens at an earlier than expected time because of higher than expected stress loads under normal conditions. At 11 hours 3 minutes 33 seconds, the crack in the engine fan blade reached its limit, and while passing flight level 320, crew heard a loud bang. In the cockpit, it felt like an explosion. The aircraft suddenly rolled to the left side with a bank of 41 degrees. None of the crew knew what just happened. Left engine N1 decreased from 99.5 to 61.5%. The vibrations increased and the whole aircraft started to vibrate. Left engine was severely damaged, and within just 6 seconds, the cockpit was filled with a warning alarm. The cabin altitude warning started to sound, indicating that the cabin is depressurized. The first officer, with the startle of what's happening, rolled the aircraft to wings level. The crew now were faced with not one, but two emergencies at the same time: engine failure and cabin depressurization. Pilots are trained for a lot of emergencies, but these two at the same time will require experience and skill, which both these pilots had. Both the crew donned their oxygen masks, as in line with the initial steps during depressurization. The first officer moved both thrust levers to idle to start the emergency descent. In the cabin, all passengers donned their oxygen masks as well. The engine fan blade had broken off, which led to further damage to the engine and the cabin window. Engine fan cowling got separated and hit the window of seat 14A. Unfortunately, the passenger seated was injured. As the aircraft was descending to a safe altitude of 10,000 feet, where humans can breathe safely without the oxygen mask, the crew identified the damaged engine and put its fuel control switch to cut off to shut down the engine. The aircraft now was in a rapid descent, with only one engine operating and the other engine damaged. Captain then transmitted to the ATC.
Southwest 1380 has an engine fire descending.
Controller asked where they would like to divert, with the captain replying,
Give us a vector for your closest.
The controller then suggested Middletown Airport in Pennsylvania and gave them a heading of 250 degrees. Both the pilots looked at the ND or navigational display and decided to divert to Philadelphia Airport, or Philly for short.
Okay, heading 250. We're looking at Philly.
Captain then started to read engine fire, severe damage or separation checklist from the QRH, or Quick Reference Handbook. QRH is a book where all the checklists for emergency or non-normal conditions are there. ATC then cleared them direct to Philadelphia and gave them clearance to descend to 10,000 feet. The pilots were doing what every pilot is taught: to aviate first, means fly the airplane, navigate, take the aircraft where you want it to go, communicate, to talk with the ATC, cabin crew and passengers. Soon the captain announced on the PA system that they will be diverting to Philadelphia. The pilots were not aware about the situation in the cabin, and what damage the engine failure had made in the cabin. At 11 hours 9 minutes, the captain took controls of the aircraft and became the pilot flying. Southwest Operations Manual says that if the landing is to be conducted with one engine only, the captain should be the one doing the landing. It had nothing to do with the first officer's flying skill. He was doing his job perfectly. It was just the Southwest policy for captain to be the pilot flying during an engine failure. From now on, the captain was the pilot flying and the first officer was the pilot monitoring. First officer now continued reading the engine fire, severe damage, separation checklist. They contacted Philadelphia approach and ATC cleared them down to 6,000 feet. As they closed into Philadelphia, the first officer reminded the captain that we need more time because still there were a couple of checklists left to complete. They needed to complete 3 checklists here. Number 1, engine fire, severe damage, separation checklist for the engine failure. Number 2, cabin altitude checklist for the rapid depressurization. And number 3, 1 engine inoperative landing checklist for the landing with 1 engine working. Doing all these checklists will take not much but some time. Should the pilots complete all the checklists before landing in an emergency situation? Well, the answer is yes and no. If the pilot thinks the emergency is very time critical and not doing a checklist will not affect the safe operation of the aircraft, in that case, they may just go in for the landing. ATC asked them that did they wanted to land immediately or they wanted extended finals to give them more time to finish the checklist. Captain replied that they would like the extended final. They were told to expect runway 27 left for landing, which was the longest runway in Philadelphia. First officer then tried to call the cabin crew to see what's the situation back in the cabin. But he got no reply. Because of the loud noise of the wind in the cabin crew was first unable to hear the call from the cockpit. About 30 seconds later, the cabin crew were able to get in touch with the first officer and told him that a window is broken with 1 passenger injured. First officer then told the captain about the passenger and the open window. In 737 generally, flaps 15 is used when landing with 1 engine. The captain, being so experienced, analyzed the overall situation and decided to land with flaps 5 rather than flaps 15. Landing with flaps 5 meant having a higher landing speed compared to when landing with flaps 15. But a higher speed would give better control over the airplane with the damage to the engine because the damaged engine was producing lots of drag. Since they were landing on the longest runway at Philadelphia, so higher landing speed won't be an issue. The captain now just wanted to land the aircraft after hearing about the damage, so she turned the aircraft towards the airport. Still, they were left to complete the checklist, but with 1 passenger injured and the damage to the aircraft, they wanted to land immediately. They configured the aircraft for landing. With all her previous experience, the captain kept the aircraft stable on the approach. As they approached runway 27 left, the cabin crew gave commands to the passengers.
Heads down, stay down.
After 17 minutes from the explosion in the engine, they safely landed on runway 27 left in Philadelphia. They stopped the aircraft, shut down the engines, and the ARFF came on board to check the injured passengers. The captain pulled the circuit breaker for the cockpit voice recorder to save the voice recordings for the investigation. After dealing with 2 emergencies simultaneously with a damaged engine, in a high stressful situation, the pilots remained calm, did what they were taught to do. What happened with Southwest 1380 is known as FBO, a fan blade out event. Fan blade is the blade that you see in front of the engine spinning at high RPM. In the cockpit, its RPM is shown as a percentage and named N1. Boeing 737 fan blade is 11-inch in width at the widest part. It is made of titanium alloy Ti64. It is very strong and has a very good strength to weight ratio when compared to steel. This is a video during certification of the engine while conducting a fan blade out event. These tests are done to check if the blade inside the engine fails or breaks. All the damage will be sustained or contained inside the engine, and the engine will automatically shut down without any further damage to the engine or the aircraft. The fan case and the engine inlet is also made of strong aluminium alloy to provide strength during an FBO event. CFM 56-7B engine got certified in 1996. The problem was that during that time, these tests were done without the fan cowl placed on the engine. This was a standard practice during the early 90s to test the strength of the fan case and its components. The technology during early 90s was also not advanced, like today, to do those tests. CFM provided Boeing with fan blade out test results. Boeing then designed engine inlet and fan cowl. So the fan cowl certification for an FBO event was done by Boeing on the basis of analysis, not real testing. During Southwest Flight 1380, the fan blade on the left engine, blade number 13, developed a low cycle fatigue crack. It fractured at the blade root, hit near the fan case at 6 o'clock position, and then fractured into multiple fragments. Some of the fragments traveled in the aft direction, which is the direction of the airflow, but some traveled in the forward direction into the inlet of the engine. Fragments entered the inlet along a forward helical path. These fragments had sufficient mass and energy to damage the fan case and the engine inlet, which damaged the fan cowl and made it to depart the engine, damaging the window of seat 14A and depressurizing the aircraft. Unfortunately, the passenger seated on seat 14A was fatally injured. The pilots did not complete their emergency checklist, but that was completely understandable, seeing the high workload situation that they were in. Southwest policy also allows to deviate from operations procedures if the captain thinks it is the best action in the interest of flight safety. CFM issued a service bulletin for mandatory ultrasonic inspection of the fan blades to check for any internal fatigue cracking in the fan blade. At the end, the pilots did a great job. Their previous Air Force, Navy experience came into play. They did follow the basic principle of flying: aviate, navigate, communicate. They showed how to go beyond things that are written in the books and how to prioritize things of most importance first.